Welcome to the Deep Dive, your shortcut to being well-informed. Today we're embarking on a really compelling journey into the world of computer science. We're going to try and uncover its fascinating evolution, explore its many diverse specializations, and maybe peek into some truly mind-bending future horizons. Our mission for this deep dive: to quickly distill the most important insights from, well, a collection of technical briefings and a foundational video. The idea is to help you become truly well-versed in this dynamic field. Our core sources are computer science, evolution, specializations, and future horizons, and P1, secured software engineering, a multidisciplinary holistic study, computer science fundamentals, which also includes an insightful YouTube transcript.
Yeah, and understanding this broad landscape isn't just for tech insiders, It's really crucial for anyone who's curious about how our digital world works, or frankly, anyone who wants to navigate the technological shifts that are, well, already reshaping our lives. The insights we'll dig into today should give you a pretty solid foundation.
Okay, let's unpack this then. When we talk about computer science, it's often described as truly multidisciplinary. What does that actually mean? Does it break down neatly into different areas?
It does, absolutely. Our sources draw a really fundamental distinction between theoretical and applied computer science. Think of theoretical as focusing on the why and how at the deepest level. It's about exploring the core frameworks, the underlying math, the physics behind computation.
Okay, so the really fundamental stuff.
Exactly. This is where you find things like mathematical models, algorithms, automata theory, which is the study of abstract machines, formal languages, the mathematical basis for programming languages, and even quantum computing theory. Careers here, often deep foundational research.
So it's the pure science behind it all, grappling with computation itself. What about the doing side, the practical application?
Right, that's applied computer science, often called the engineering side of the field. This branch is all about the practical application of those theories. Think hardware engineering, software engineering, infrastructure engineering.
Makes sense.
And it's where you find the specializations most people hear about. Artificial intelligence, databases, networking, cybersecurity, human-computer interaction. It's really about building things, implementing them, making them work out there in the real world.
Got it. So if someone's thinking about getting into the field, or maybe just trying to understand the different careers, what are some of those key specializations? Any surprising roles emerging?
Oh, the landscape is huge, but some areas are particularly critical right now. Take algorithms and data structures, absolutely foundational. Our sources literally call them the backbone of today's AI, data science, and, everything related to models like ChatGPT or Gemini.
The backbone. Okay, so without them, none of this fancy AI stuff works properly.
Pretty much. They're the recipes, the organizational principles that make complex systems efficient. They simply wouldn't function otherwise. Then, of course, you have the more familiar programming and software development, roles like software engineer, full stack developer, mobile app dev, DevOps, even game developer.
Right, the people actually writing the code.
Exactly. But it goes beyond just coding. There's system architecture that includes fascinating areas like embedded systems, the specialized computing inside your car, your washing machine, medical devices.
Ah, the smart stuff everywhere.
That's it. And of course, cloud infrastructure engineers are in huge demand, managing all that online computing power we rely on.
And all that tech needs data, right?
Absolutely. Which brings us to databases and information systems. Vital, because data today isn't just text anymore. We're talking vast amounts of multimedia, audio, video, images. Managing that is a whole domain in itself. And then the hot domain, artificial intelligence and machine learning. Still redefining everything. Deep learning, generative AI, agentic AI. The roles go beyond just engineers and researchers now. You've got computer vision specialists, even AI ethics consultants.
An AI ethics consultant?
Yeah.
Wow. That really highlights how fast things are moving, doesn't it? That role wouldn't have existed a decade ago.
Yeah, it really wouldn't have. And for those interested in how we interact with tech, there's human-computer interaction and graphics. Think UX, UI design, computer graphics, VR, AR development, shaping that user experience.
Okay.
But where it gets, I think, really interesting is interdisciplinary applications. Fields like bioinformatic algorithms merging biology and computing, digital humanities, computational linguistics, and the sources even mention roles like techno-philosophical consultant or knowledge representation engineer.
Techno-philosophical consultant. I'd love to see that job description. It just shows the incredible breadth. Okay, so the sources stress that history is key to understanding the future here. Let's take that journey back. Where do we start?
Right. Let's start with the foundational period, roughly the 1930s to the 1950s. Big moment, 1936. Alan Turing publishes his work on computability, introducing the Turing machine concept, the abstract model of a computer.
The theoretical blueprint, basically.
Exactly. Then, 1945, you have von Neumann outlining the stored program architecture. That's fundamental to how, well, pretty much all our computers still work today.
So the core ideas were laid out way back then. Incredible.
It really is. And Turing wasn't done. In 1950, he proposed the Turing test for machine intelligence. The sources stress how relevant that still is today. A game changer for AI thinking.
Still debated, yeah.
Definitely. And just 6 years later, 1956, the field of artificial intelligence gets its name at the Dartmouth workshop. It's kind of wild to think AI is officially almost 70 years old.
70 years. That's quite a history.
Okay.
So after those foundations, what about the languages and systems that actually made computers usable for more people?
That brings us to the language and system revolutions, say, the 1970s through the 1990s. 1971 is a key year. Dennis Ritchie starts work on the C programming language, hugely influential, and around the same time, UNIX development kicks off. It pioneered standardized open operating systems.
C and UNIX. Legends.
Absolutely. And Linux, which branched off UNIX, is still dominant for servers today. Then in the 80s, C++ comes along, introducing object-oriented thinking. The sources describe this as a sort of preliminary stage for today's AI because it allowed mapping real-world concepts into code more directly.
Building digital models of reality, in a way.
Precisely. And then, 1989. Tim Berners-Lee at CERN invents the World Wide Web. Suddenly, the internet is open to the public. A total revolution.
That really did change everything for, well, everyone.
Transformed society, yeah. Then Java followed, bringing platform independence. That whole write once, run anywhere idea using virtual machines, that was massive for software. Oh, and this era also saw IBM's Deep Blue beat Garry Kasparov in chess, a big public AI moment.
I remember that. And then came the internet really taking off, and the mobile revolution. That made tech so personal, didn't it?
Completely. The internet and mobile era, late 90s through the 2000s, was profoundly transformative. Google search changed how we find information, and then 2007, Apple launches the iPhone. That just catalyzed the whole modern mobile and app ecosystem.
Right, the smartphone era begins.
Yeah. The mobile world, as the sources put it, you suddenly had a powerful computer right there in your pocket. And Web 2.0 brought social networking, a totally new channel for communication and everything else.
Which brings us closer to today, with AI and cloud computing just dominating the headlines constantly.
Exactly. The AI renaissance and cloud computing period, from the 2010s to now, has been incredibly fast-paced. IBM Watson winning Jeopardy was another one of those big AI milestones early on. Then 2012, the AlexNet breakthrough really showed the power of deep learning, especially for images.
That felt like a turning point for AI research.
It really was. And alongside that, cloud computing took off. Things like Docker, providers like AWS, Azure, Google, they fundamentally changed how we manage infrastructure. No more needing massive server rooms for everyone.
Yeah, shifting from on-premise hardware.
Totally. Then, more recently, 2019, Google announced quantum supremacy with their Sycamore processor, a big step for quantum computing. And then 2023, foundation models like GPT-4 started reshaping natural language processing and AI services. The AI revolution really kicked into high gear, followed quickly by things like Google Gemini.
It feels like we're right in the middle of another massive shift. What's fascinating is that the sources don't just stop there. They actually map out the future. What are they predicting for, say, 2025 to 2040 and beyond?
The vision is pretty remarkable and ambitious. In advanced AI, the trajectory is clearly towards general AI research, thinking about augmented systems, formal verification, and then you get into concepts like transhuman singularity, superintelligence, maybe even artificial consciousness and artificial emotions.
Wow. Superintelligence, artificial consciousness. That's heavy stuff.
It is. And things like digital twins, these virtual replicas of physical systems, also fall under advanced AI. Huge potential for simulation. Quantum computing remains a major focus too, pushing towards true quantum supremacy and figuring out quantum error correction to make them reliable.
Making quantum actually usable for real problems.
Exactly. And then, really importantly, there's sustainable computing. A growing emphasis on carbon-negative tech, biodegradable hardware, energy harvesting, zero waste technology.
Biodegradable hardware. Seriously, like computers that decompose.
That's the idea. It sounds like sci-fi, but it's being researched, driven by environmental needs. We're also seeing hints of biocomputing, using synthetic biology, maybe even DNA data for storage.
DNA data storage. The density would be incredible.
Mind-bogglingly dense. Then in network evolution, you have ideas like space-based internet, neuromorphic networking networks modeled on the brain, and even quantum teleportation for secure data transmission.
Quantum teleportation. Oh, hopefully just for data for now.
For now, yes. And how we interact is set to change too. Under human-computer interfaces, they talk about brain-computer interfaces, direct thought control, haptical or holography for immersive experiences, emotion-aware systems, even direct neural network interfaces.
Directly connecting our brains to computers.
That's the frontier. And finally, cybersecurity has to evolve alongside all this. We're talking quantum-resilient encryption, self-healing networks, dealing with AI-powered threats, implementing zero-trust security models, and using homomorphic encryption to compute unencrypted data.
Keeping data secure even while it's being processed. That's crucial. Wow, what an absolutely incredible deep dive. From those early theoretical ideas and the revolutions in hardware and software, right through to the current AI boom and this, well, frankly, mind-bending future of superintelligence and biodegradable computers. Just constantly astonishing.
It really is. It's this dynamic, constantly expanding field that just keeps redefining what's possible. And understanding that evolution, that history, and the future trajectory helps you make sense of the present, but also hopefully anticipate some of the huge changes still coming our way.
Absolutely. So, as you reflect on this journey we've taken through computer science, here's a thought to leave you with. If this pace of innovation continues, maybe even accelerates, what profound ethical dilemmas are going to emerge right at that intersection of human consciousness and increasingly sophisticated artificial intelligence? And perhaps more importantly, how prepared are we, really as a society, to navigate them thoughtfully? Thanks for joining us for this deep dive. We hope you feel a little more well-informed and maybe even more curious about the ever-evolving world of computer science.